So there are two levels of monopolies here. So the firm is maximizing profit, and the worker are maximizing their revenue as well. So we need to divide this problem into two parts. First is profit maximization, and second is the revenue maximization. Uh, the, so we should probably do this one first. So to do firm profit max, we always had MR equal to MC. So we need to calculate them separately. So total revenue, again, is just P times Q. And P is given by the demand function. So demand function is here. So we have Q is equal to 1000 minus 10P. So invert this, we get P is 100 minus Q over 10. So we're just rewriting this and substitute this in here. So so it's 100 minus Q over 10. This is Q times Q. And then we differentiate to get this. So we find the derivative of TR, which is equal to this thing derivative is 100 minus Q over 5. So, but that's part one. That's one part of part one. And total cost is, from the question, we need 1 unit of labor and 1 unit of plastic. So what it means is the production function is the minimum of amount of labor and amount of plastic. So this P is plastic, I'll use PL. So if we have a production function like this, then it means they are equal and they are both equal to Q. So then we have the price of labor is C, or we call it wage W times L plus the cost of plastic is $10 here. So we have $10 times plastic. And as I said, both of them are equal to each other and they are also equal to Q. So we have W plus 10 times Q. So of course we have the marginal cost there. It's W plus 10. So that will be the first step, and then we can calculate Q. So 1000 minus this, 100 minus Q over 5 is equal to W plus 10. Here, the W we can treat it as a constant. So this step is setting MR equal to MC, and then we can solve for Q, which is multiplied by 500 minus Q is 5W plus 50. So Q is equal to, move this to the other side, 500 divided by 5 is, I think this is making it harder to solve. But anyways, so the next step, so this is corresponding to the second step. So the total revenue of the worker is the number of worker multiplied by each person's wage, which here, as we did, L is equal to Q. So we have this relation. And then we could multiply them, I think. So I think doing it this way may not actually be good, because then we are differentiating something that's complicated. Let's, oh no, it's actually okay, I'm sorry. This thing is wrong. This thing is moving Q to the other side. It's just Q is equal to 450 minus 5 W. I'm sorry, that expression was wrong. So then I thought it's harder to differentiate this way. But anyways, if we solve correctly, we substitute this in, then we get this expression. And then we are trying to maximize this. So what we call the first order condition, or the marginal benefit equal to 0 condition, is try to differentiate this. So the derivative of this thing, we set equal to set to 0, and then we have 450 minus 10W is equal to 0. So again, when you are trying to do profit maximization, you do MR equal to MC. When you are do anything else maximization, you differentiate whatever this thing is, and then set that thing equal to 0, and then we can solve for W equal to 45. So is there an answer? Yes. C.